All right, lesson 7.6.1 is solving exponential equations. Now this is everything, what this lesson is actually going to do, and this one may take you a little longer, maybe a couple days to actually do it. So I would suggest doing this one in phases, maybe doing the first video, doing some practice problems, doing the second video, doing some practice problems, doing the third video, and then doing some practice problems. And make sure that you fully understand how to do this before you really move on to the quick check and the quizzes and the unit test, because this is basically the reason that we've been studying the previous 5 lessons comes down to this one lesson and actually being able to solve the exponential equations, okay? And what this actually turns into is, you know, before we've had problems where it was like x squared equals 81, and the variable was actually the one being raised to the second power. Now we're actually getting problems where the variable is actually going to be in the exponent spot. Okay, so let's take a look at this, because each of the 3 videos takes a different strategy on how you need to solve these problems. Okay, so the first one is, let's say I have 3 to the 3x equals 3 to the 2x plus 4. Okay, so if we're basically these are evaluating when you have exponents. Okay, if you have an exponent in both spots, then what you need to do is you are going to rewrite each power with the same base. Okay, remember the power to power you would multiply. We're going to evaluate exponents that each of the powers equal to each other. So basically, if the bases, and remember the 3 here is our base, so if those bases are exactly the same, all you have to do is set the powers. Your power is 3x and 2x plus 4. And you're just going to set those equal to each other. So 3x equals 2x plus 4. In other words, you just knock off the bases. Okay? When you're done, solve them. 2x. So x equals 4. Okay? And that's it. That fast, that easy. Okay? So go ahead and do the next one, the u try. 5 to the 4x plus 6 equals 5 to the 7x minus 3. Okay, all right, and if you notice here, our bases, which are 5, are exactly the same. So again, you can just knock them off, and all you're going to do is 4x plus 6 equals 7x minus 3. Okay, so minus the 4x. 6 equals negative 3x minus 3, and add the 3. Now, you could have subtracted 7, so just because you didn't solve it the way that I actually did doesn't mean anything. You're perfectly fine. So x in this case is going to equal 3. Okay. The rest of this should just be basically solving equations when the variable ends up on both sides. Okay. Now, there are a few rare occasions when you're going to run into problems where the bases are not exactly the same. So then you got to think about, and this is where that exponent sheet in chapter 6 is going to become really helpful if you're looking at it. Because what it's actually going to do is you need to find the row where those are exactly the same. Okay? So actually, let's just go ahead and pull that exponent sheet up real quick from chapter 6. Okay, so here's the exponent sheet, if you'll remember. And if you'll look, you notice that 4 and 8 both end up in the row of 2. So we're going to change their base so it has a base 2. Okay? So let's go ahead and, so we need to change this to, instead of 4 to the 3x, we're going to change it to 2. Well, 2 to what power will give you 4? And 2 squared gives you 4. And remember, so we got to, and when we do this, we're going to end up multiplying these powers, okay? Because the 2 squared gives us the 4, and we already had the power of 3x. And you're going to do the same thing with the 8. But if you remember, man, 2 to the what power will give me 8. And you find out that it's 3. So 2 to the 3rd will give me the 8. So 2 to the third gives me the 8, but I also need the x plus 1. Okay. Now if you notice, my bases are exactly the same. So you can knock off your bases, and you're going to have 2 times 3x equals 3x plus 1. Okay. So 2 times 3x gives you 6x. Distribute 3x plus 3, and then I just minus the 3x. So I get 3x equals 3. The rest of it, again, just turns into a solving equations problem. So x equals 1. Okay? So that's it. So let's go ahead and do another u-try. Okay? If you're not comfortable with it, wait a few seconds in the video. Go ahead and start. So, okay. All right, so remember, the first rule is you have to have the bases so they are exactly the same. Okay? So right now my bases are 2 and 32. Okay, so if I'm looking at this, I need to find a row, including the black row, because I may not have to adjust that. Okay, I may not have to raise it to a different power. But you find out, oh, wait a minute, 2's here, and I have 32. Okay, now this is not an exclusive list. We only went to the 5th power. Remember, you can go to the 6th power, the 7th power, the 8th power, and actually to infinity. It doesn't stop. So 2 is actually my base, so it's not going to change. 32 would be 2 to the 5th power. So this side over here is going to turn, 32 is going to turn to 2 to the 5th, and I got to keep my x minus 1. And this side is going to be 2 to the 4x. Okay? So now that my bases are the same, I can actually just solve this. So 4x equals 5 times x minus 1. So 4x equals, distribute, I get 5x minus 5, and then subtract my 5x. So negative x equals negative 5, and then divide by negative 1. So x equals positive 5. Okay? All right. Now, occasionally, changing the bases isn't actually going to be exactly the same. Now, if you have a variable on both sides, typically that's the way that you're going to have to do it. But if you go back to your exponent page, 2 is one of your prime numbers that we can't raise it to a power. But if you quickly notice, 7 is not included as a, you can't raise 2 to a power to get 7. So in this case, what you're actually going to do is, you are actually going to take the log of each side. Now, what you've got to look at is, okay, where's my exponent? My exponent is here, 2 to the x. So what I'm actually going to do is, I'm going to put whatever the base of this exponent is, which remember my base is the 2, then I'm going to add the log base 2 of both sides. Okay, so whatever the base is, that's what my base of my log is going to be. So log base 2, and then 2 to the x equals, if I add a log base 2 over here, I got to do the exact same thing over here. So log base 2 of 7. Okay? And then if you follow your rules, remember your exponent rules, you find out that this x, anytime you have an exponent, remember, comes out front. So x log base 2 of 2 equals log base 2 of 7. Okay? Now, if you remember, log base 2 of 2 is what? Remember, we do our circle bin. 2 to what power will give us 2? And you find out x has to be 1. So anytime you have this number and you have this base that are exactly the same, they cancel each other out. And you find out x equals log base 7 over, oops, sorry. Let's back up a second. I'm getting ahead of myself. You find out x equals log base 2 of 7. Okay? And then the way you're going to evaluate that is because we actually need an answer. Log base 2 of 7 is not the answer for this problem. And the way you're actually going to need to solve that is you're going to do your change of base formula, just what we did in the previous lesson. So x equals, remember the base goes in the basement, so log 2 goes in the bottom, and log 7 goes on top. Okay? So if we use our scientific calculator, remember, we're going to do, let's clear this out. We're going to do log 7 divided by log 2 equals. and you find out your answer is about let's go 3 decimal places, 2.807 as your final answer. So in other words, if you took 2 to the 2.807, you're going to get 7. Okay. All right. So let's go ahead and try a U-try. So there's the directions. But if you need to, you can rewind the video and use the last one as an example. Okay, so let's go ahead and try this one. Now, if you look at your exponent sheet again, can I get the same bases? And you're going to find out, man, no, I can't get the same bases, because here's where 4's at, and 15's not included in there. And even if I tried to rewrite the 4 as a power with a power of 2 with a 2 squared, 15's not in that row either. So whenever those things occur, and I don't have an x in my other exponent, then remember you're going to do the log. But you've got to look at, here's my exponent, so it's going to be a log base 4. So we're going to do log base 4 of 4 to the x equals, because the base of this and the base of the exponent should be the same. If I add a log base 4 on the left side, I got to add a log base 4 to the other side. So it's going to be log base 4 of 15. Okay. And remember, the x comes out front when we're expanding our rules. So log base x, log base 4 of 4 equals log base 4 of 15. Okay. Remember, anytime the base of the log and the original base, that number, is the same, they cancel each other out. So x equals log base 4 of 15. Okay. All right. So, and then the last and final step is, once you get it to that phase, it turns into a change of base formula. So remember, the base goes in the basement, and it turns to log 15. Okay? All right, so let's go ahead and evaluate that. So we do log 15 divided by log 4. And let it calculate. And we get an answer of 1.95. Okay? And I'm putting little squiggly lines in there because those lines actually mean that they're approximately 1.95. All right, a couple more examples for us to go over. This one is 10 to the 2x plus or minus 3 plus 4 equals 21. Now, before you can do anything, this is just like normally solving equations. Since this is actually what's being raised to your power, then you need to make sure and get everything that is not being raised to that power off of that side. So in other words, we just need to get rid of this 4. So we're going to subtract 4. So we get 10 to the 2x minus 3 equals 21 minus 4 is going to give us 17. Okay? So now that on the left side everything's being raised to the power, so in this case I need my base of my exponent is 10. So I'm going to do log. Now remember, base 10, that's a common log, so I don't have to write it. 10 to the 2x minus 3 equals log 17. Okay? So the exponent comes out front. So 2x minus 3, we're going to put it in parentheses, just make sure we know that it's the whole thing. Log base 10 equals log 17. Okay. Now remember, log base 10, when the base of the log and the log are the same, they cancel out. So I get 2x minus 3 equals log 17. Okay. Well, at this phase, I can't do much. I can't add 3. I can't divide by 2 yet until I actually find out what that log of 17 is. So let's find out what log of 17 is. So clear, log 17 equals 1.23. So now 2x minus 3, log of 17 is 1.23, and I can finish out the problem by adding 3. So 2x equals 4.23, and then divide by 2. So x in this case is 4.23. Oops. 4.23 divided by 2 gives me 2.115. That's my final answer. Okay? All right. So the last example is a U-try. So go ahead and pause the video and see if you can solve this one on your own first. All right. So remember, when we do this, the first thing is you've got to subtract 3. So 5 to the x plus 2 equals 22. And remember, now I got to get that variable out of the exponent. So the way you do that is you log it. Remember, the base of the exponent and the base of the number have to be the same. And I got to add log base 5 of 22 on this side. Okay. So the exponent comes out front. X plus 2 log base 5 of 5 equals log base 5 of 22. Okay. So when the base of the log and the number are the same, remember they go away. So x plus 2 is all that's left over here. And so I get log base 5 of 22. Well, before we can just subtract 2, we actually got to find what that log base 2 or log base 5 of 22 is. And the best way we can do that is change the base formula. So I get x plus 2 equals, remember the base of the base of the log goes in the bottom, so log 5 goes in the bottom, log 22 goes on top. Okay? So if we calculate what log of 22 divided by log 5, oops, we forgot our divide sign. Log 22 divided by log 5. 1.92. So x plus 2 equals 1.92. And then you're going to minus the 2. So x equals a negative 0.08 as your final answer. Okay? All right, well, this concludes video lesson 1. This is probably the longest one. The little one's more challenging. The others will get just a tad bit easier. So, but if you have any questions, make sure you either message me or make sure you contact me with the phone number that's listed on Angel. Thanks.